Okay, now we're going to calculate the equation of a perpendicular bisector of a line segment joining 2 points. So we're going to use the same example as last time, the same 2 points, but this time I'm going to calculate the equation of the perpendicular bisector of 2, 1 and 10, 17. So I've already got the line that passes through 2, 1 and 10, 17 in place, and we know from the previous example that that had a gradient of 2. So I'm just going to sketch the perpendicular bisector in. It crosses at right angles halfway between those 2 points. So the first thing I want to do is calculate this midpoint. So the midpoint is going to be the mean of the x and y coordinates. So 2 plus 10 over 2 and 1 plus 17 over 2. So the midpoint is going to be 12 over 2, which is 6, 18 over 2, which is 9. So this coordinate here is the coordinate 6, 9, halfway between these 2 points. So the perpendicular bisector is going to go through the point 6, 9. It's going to be perpendicular to the original line. The original line had a gradient of 2, so the perpendicular gradient is the negative reciprocal of the original gradient, so that is going to be negative 1/2. As it's a straight line, it has the same equation to start off with, y equals mx plus c, and we now use this perpendicular gradient to say it's going to be y equals negative 1/2 x plus c. To find the value of c, we once again substitute a point that we know lies on that line. The only point we know lies on this perpendicular bisector is the midpoint 6, 9. So we're going to use the point 6, 9 substituted into this formula. 9 is the y coordinate and 6 is the x coordinate. So 9 equals negative 1/2 times 6, which is negative 3, plus c. So rearranging to get c equals 9 plus 3, which is 12. So putting the 2 parts together, the gradient and the intercept, we get y equals negative 1/2 x plus 12. And that's the equation of this perpendicular bisector. If we go back to my original diagram here, it's not unrealistic to see that that y-intercept there is 12.